This is the homework video 449. We're on page 237. So we're looking at absolute value equations. And number 2, we're going to determine whether the number given for A, B, C, and D is a solution to this equation. So everything goes back to 60 equals the absolute value of n minus 90. But the key is you always solve the inside of absolute value. And then at the very end, when you have it down to just a single number, you take the absolute value of that, which, reminder, is just makes it positive. Okay, if it's positive, it stays positive. If it's negative, it becomes positive. So letter A, we're testing 30. So we're going to plug it in. 30 goes in for n. 30 minus 90 is negative 60. Absolute value of that is 60. So we get 60 equals 60. So to answer the question, is this a solution? Yes, 30 is a solution. Letter B, negative 30. So 60 equals negative 30 minus 90. Well, that's negative 120, and you take the absolute value of that, it's positive 120. So the answer here is no, not a solution. Letter C, 150. 150 minus 90. That gets us 60. Absolute value of 60 is 60. Again, a positive number, when you take the absolute value of it, stays positive. The answer to any absolute value is positive. It's never negative. Okay, so this is a yes. And letter D, negative 150, so 60 equals negative 150 minus 90. One big mistake people make is they think that because there's absolute value, everything on the inside just becomes positive. That's not true. You go ahead and you solve this inside. So this would be negative 240. Then you take the absolute value, so it's positive 240. So obviously this is a no. Number 3, find the solutions in your head. So the absolute value of A equals 6. So what numbers could it be? Well, it could be 6, but it also could be negative 6, because when you take the absolute value of negative 6, you also get 6. Number 4, the absolute value of whatever B is negative. We just talked about you can never get a negative number when you take the absolute value. So there's no solution here. You cannot get a negative. It's not possible. Number 5, the absolute value is 0. There is no positive or negative 0. So the only possible answer you could plug in here is just 0. In number 6, 5 times something equals 40. So the absolute value of D has to give me 8, because 5 times 8 is 40. So what numbers, when I take the absolute value of them, give me 8? That's 8, obviously, and negative 8. Okay, number 7. So the table at the right is giving you the values. So if I plugged in negative 5, negative 4, negative 2, 0 for 2x minus 3 absolute value, these are the answers I would get. So they could have asked you this without giving you the table. Now, the table confuses people, but they're literally giving you the answer, so you don't have to do any work. And they're comparing this to 7. When is it equal to 7? When is it less than 7? When is it greater than 7? What values of x produce those values? And so they've included this right here in the table, and that can be a little confusing when you see it. This is the line y equals 7, which would be a horizontal line where the y value is always 7. And so we're just looking at the table and comparing. When does this expression, the absolute value of 2x minus 3, give us values that are equal to 7, less than 7, or greater than 7? And our answer is going to be based on the x values that are plugged in. So letter A, probably the easiest of them. When does this give you the answer 7? When is it equal to 7? 2 spots. Okay, when you plug in negative 2, and when you plug in 5. 5 times 2, that's 10, minus 3 is 7. Absolute value of 7 is 7. When you plug in the negative 2, 2 times negative 2 is negative 4, minus 3 is negative 7. So I get negative 7 in here, but the absolute value makes it positive 7. So again, you can plug these numbers in yourself, but they've already given you the answers. That's what this is. Okay, so the two values that make this equal to 7 are x equals negative 2, and the other one is 5. Letter B. They want to know when do we get values that are less than 7. So it's everything in between here, because you can see, look, 3 and 1 and 1. Now some people just want to list off these x values, so they want to say, well, when x equals 0, 1, and 2. But what about negative 1? And what about all the decimals in here? What about at 1.5 and 1.2 and 2.3? You can see that it hits, and they're always going to look like this on the graph. It hits and equals right at negative 2 and right at 5. And anything in between that on the graph is going to be less than 7. And so we have to express that as an interval, as an inequality. So everything between negative 2 and 5, greater than negative 2, but also less than 5. So what does that look like? X greater than negative 2, x less than 5. Letter C, when does this expression give us values greater than 7? So anywhere above here on the table and anywhere below here on the table. So what are those x values? They're anything from, don't start at negative 4, because even if, like, look, there's no negative 3. But based on the fact that this hits at 7 and would be going up from there, I know negative 3 would be bigger than 7. So I need to include that in my answer. So it's everything less than negative 2, and it's everything greater than 5. So when x is less than negative 2, when x is greater than 5. This would be an or statement, by the way. There's no way to be an and statement there. You can't be in both. So it's either less than negative 2 or it's greater than 5. Okay, we jump to number 9, which is a very similar question, except instead of a table, they've given you the graph. But here it is again. So for all of these values, we're comparing it to 10. There's the line y equals 10. For all of these values in here, this expression, which is obviously the absolute value of x plus 5, that's what they're telling you, is less than 10. Right on those dots, it's equal to 10. And then up here above that line, it's greater than 10. So the green portion, if you notice, is above it, so where it's greater than 10. But it also includes the dots on the line. So they want you to pick which one of these represents the solution here for the green ones. So it's where this expression is greater than 10, but also equal to 10. So which one of these says that? This one says just equal to 10. So if I highlighted that, it would just be the dots. This one says less than or equal to. It would be everything underneath plus the dots. And then C and D, the only difference between these is one has the equal sign, one doesn't. So you have to check, is 10 included, or is the green just representing everything greater? Because the dots are green, it's including 10. So we also have to include 10 there. So the answer is C. All right, and now we're just running 11 through 13. So solving these equations out. So this absolute value gives you the answer of 12. A plus 10 equals 12. But you just got to think for a second. Forget what's in here right now. In order for this to give me an answer of 12, my final value in here is either 12, but it also could be negative 12. Because if I get negative 12 as my answer, the absolute value of negative 12 will also give me this answer. So there's two possible answers. I need to solve it both ways. So a plus 10, that could have given me 12. That makes sense. But a plus 10 inside of here could also give me negative 12, and this would be true. Because if I get negative 12 in here, the absolute value makes it positive. So I have to find out what value of a gives me 12 and what value of a inside here gives me negative 12. So you just solve these two. Minus 10, so a equals 2. Minus 10, a equals negative 22. So these are both possible answers. A equals 2 or a equals negative 22. Let's go to the page now. 12 and 13. 42 minus 3b equals 45. So this expression inside the absolute value has to give me one of two things. Either 45, so when it's absolute value it stays 45, or it gives me negative 45. And when that happens, the absolute value again makes it positive. So I have to solve it for both possibilities. So 42 minus 3b could have given me 45, but 42 minus 3b also could give me negative 45, and it would still make this true. All right, so I'm going to minus 42. It's negative 3b, positive 3, divide by negative 3. So b equals negative 1. Over here, minus 42. negative 3b. That's negative 87. Divide by negative 3. That's going to be a positive. I don't know why. Right, that's going to be a positive. Yep. 29. So this is an or statement here. Okay, it's either b equals negative 1 or it's b equals 29. So both possibilities we have to account for. Inside of here, we could have got 45. When you take the absolute value, it stays 45. Or we could have got negative 45. And then that's what we did here. Last one, number 13. This is where it can get a little confusing. So this value in here needs to be less than 9. So we can solve it for the numbers less than 9. 8 minus c less than 9. And that accounts for our positives. But what about negatives? For this to be less than 9, that would be numbers like negative 5, negative 4, because when they become positive, they are less than 9. So we always have to compare it to the negative version of this. It's going to look like this. That's the quick way to do this. And so we're actually looking for when is it greater than negative 9. So you can split this in two pieces, or you can write it like this. I suggest you start like this. Write it the way you see it, and then make it greater than the negative. Or if it was facing this way, you're going to keep it facing that way for the negative. So you make these face the same way. So it's less than 9 or greater than negative 9. You basically flip it. So if you were writing it separately, you would have probably done this one first. 8 minus c is less than 9. And then you would have wrote 8 minus c is greater than negative 9. And that says the same thing as this. So I'm going to work up here, but you could have wrote it as two separate ones and solved it. So I'm going to solve it all at once here. I'm going to minus 8 from all three spots, leaving me negative c. So this is negative 17, and this is 1. Now I have to divide by negative 1. Now here's where it can get a little tricky when you're doing it all at once. When you divide by a negative, everything flips. So these are going to have to flip. So c, these flip like this. This is negative 1, and this is positive 17. And this is my final answer right here. Normally, though, when we write these types of intervals, this is correct. But when we write these, we normally put the smaller number on the other side, right? So we write negative 1, and we write 17 like that. So that's what you're going to see on your answer key. So you might think this is wrong. But if you notice, it's open towards the c when it's being compared to the negative 1. So open towards the c when compared to the negative 1. Closed towards the c when compared to 17. And that's the answer on the answer key. These are equivalent. These say the same thing. If you would have solved these separately, this first one, comparing it to the 9, you would have got this negative 1. So you would have minus 8, just like we did here, and you got 1. Divide by negative 1, and you'd have c greater than negative 1. And then this one, you would have minus the 8 and got the negative 17, divided by the negative, and it would have flipped, and then you get the positive 17. So c is less than 17. So you would have ended up with these two, and you could write them as separate like this and say and. Both have to be true. But then you could also write it, take it from here and convert it to this. C is greater than negative 1. That's what this says. C is less than 17. That's what this says. Okay, so it can be a little confusing just coming up with that final answer. But the key is, going back to here, is knowing that we have to flip this and compare it to the negative version, because we need numbers greater than negative 9 inside of here when we're done, because a number greater than negative 9 is like negative 5, because then when that's in here and that becomes a positive 5, it actually fits this and is less than 9.